let's talk about arc length. And let's have this question, what is the arc length of an angle of a circle? Well, first of all, just a heads up, this isn't really a good question. This isn't really written well. So before we get there, we need to talk about what some things are and pull some previous information to find out really what arc length in this sense is. So we want to recall that the circumference of a circle r is 2 pi r, and also that the length of half of the circumference of a circle with radius r is 2 pi r over 2, which is equal to pi r. So that's just some information we're going to use. So let's get the notion of arc length better defined. So given this picture below, the arc length s, which is the length of this spot right here, is the length of the arc subtended by the angle theta. So you may have not seen the word subtended before. What is the arc subtended by the angle theta? Well, if we have this angle theta right here, what is the arc subtended by it? It's the arc that's defined by it. So if you have an angle and you draw lines out to the edge of the circle, it's going to be the arc that's in between there. So when we're asking what is the arc length, well, that is the length of the arc right there. So before we figure out a general formula or something like that for arc lengths, for arcs that are subtended by particular angles, let's look at these two. And actually, let's start with this one. This one's a little more clear. So what is the length of half of the circumference of a circle with radius r? Well, we found that was pi r, which was just dividing the whole circumference by 2. But if we think about what is about half of a circle, so just like the kind of semicircle, but just the rounded part, well, that is just the arc that's subtended by the angle that is half of a circle, which is pi. So we can kind of associate this length right here with the angle pi. We can also talk about this with circumference. So circumference is the full circle, and we can also think of about that as the arc that's subtended by 2 pi. So if we start here, for example, and we go around 2 pi, we end up right on the same line. So that's the line all the way around here. And that's just the circumference. So we can kind of associate the angle that is subtended by the arc for circumference, all those words, we can associate the angle 2 pi. So kind of hidden in both of these, we see that there's 2 pi times r here, and here's pi times r over here. So actually it turns out that we have this general formula that the length of the arc subtended by the angle theta is actually just r times theta, where theta is particularly measured in radians.